about running tests with Docker. I'm Manuel Weiss, co-founder and director of marketing here at Codeship and the manager of our webinar program. With me today is Laura Frank, one of our senior engineers. Laura is an expert in Docker, has been teaching about Docker and speaking about it at a lot of conferences throughout the last few years, and most recently, she's been working on Codeship Chat, our continuous integration platform with native Docker support. Let's have a quick look at today's agenda. Laura will give a brief introduction to testing best practices and why testing your software is so important. Later on, we will look into how to achieve parity between development and production environments with Docker and Codeship Chat, and how to use them to set up parallelized testing. At the end of the webinar, you will have a pretty good idea on how to run tests with Docker and what the big benefits are that come with it. Throughout Laura's talk, we will collect questions, which we will answer in a 15-minute Q&A session after Laura's presentation. You can also ask questions or share your thoughts on Twitter with the hashtag #DockerTestingWebinar. And I also want to let you know that we are recording this webinar, and I will email you the video and the presentation slides in the next few days. But enough from me now, let's get started, and I'm handing over to you, Laura.
Thanks, Danny. And thank you to all of you who are maybe giving up your lunch hour to listen in on this webinar. I hope that you'll walk away with some practical tips that you can start using as soon as you get back to your desk. We'll cover a couple topics during the next hour together. The first thing we'll look at is why we test to begin with. So if we talk about running tests faster, it's probably important that we figure out why we should be running them in the first place. We'll look at testing with Docker Compose, and then how we can take this to the next level by introducing continuous delivery and continuous integration patterns into our development cycle. And then finally, we'll talk about how we can use Docker and containerization patterns to increase the time, increase the efficiency, and to run faster tests using containers. So getting started, the big question that we should answer for ourselves is, why do we test in the first place? And I think we probably, all of us on our development teams or teams we've worked on in the past, have used some kind of testing. And in fact, testing has been a part of software development since kind of the very beginnings. We've used testing since the ENIAC machine. So if you're not familiar, this is a huge what's, depending on where you are, where you're from, considered to be one of the first computers. And what this machine was used for was calculating artillery firing tables in the ballistic research laboratory for the US Army. So these very intricate kind of trajectory tables and figuring out which angle you had to launch which weapon in order to hit a target located X distance away. It was also involved in the study that kind of informed the development of thermonuclear weapons. So this is sort of an important machine. And of course, we didn't want to have mistakes in computation. And the women who were responsible for programming this machine actually hand-checked the results with a hand-computed table. So the big benefit of the ENIAC was that it took something that took maybe a whole week, and it could be completed in a matter of a couple hours. But even so, it was still really important to take something they knew to be true and compare it to the results they were getting from the machine. And in fact, if there was sort of like a big tube that had burst, by checking the table, it was easy to figure out where the bug had happened, where the glitch had happened, so that they could repair the hardware and make the machine correct again. And this kind of can be applied, the same thinking, to the software that we write and test today, because we answer the question, does it work, in pretty much the same way. We take our expected result and then compare it to the actual result. And whether that's true or false, we can determine if the software that we've written actually is working as intended. And we do this because we want to deliver quality software to our customers. We don't want to, introduce bugs. And testing, code reviews, pair programming, version control, highly available architecture. This is just sort of one piece of the big goal that we have of working software in production. So testing is just one of the ways that we as software professionals kind of do our jobs better in order to provide the product to the people that care about it, which is working software. We can call this maybe a motivator for testing. So we think about testing sometimes as pretty tedious and maybe it's annoying, but if we think about the positive things, it's maybe easier to stay motivated in doing it. We want to update our application without breaking things. This is very important. We want to also validate the functionality of updates. We want to be able to trust our deployment checks. So if you're using a continuous integration or continuous delivery workflow for deploying your software to production, that whole process kind of falls flat if you don't have really good tests in place, because you want to be able to deploy software you know is working, but you can't know if you don't test. Another reason that testing is really important is that if you're refactoring something, if you have an integration test or an acceptance test, so kind of the user-facing big picture test, it's really easy to refactor without breaking existing functionality because you always have a reference point. So you have the expected result and you can kind of change your code to make sure that the expected result kind of stays the same. So given all of these things, a lot of us still don't test a lot. And I did a bit of an informal poll to figure out why people skip this very important step that we know it's important and we still kind of hesitate to do it. Most people say that they skip tests because it just slows down their deployment, which is pretty understandable. Kind of hand in hand is that the tests are just too slow to run. So 35% of people said, I skip tests because they're too slow. Some people think it's annoying, and then poor 5% just don't see the point in testing. I imagine those people don't support production software. But it's pretty common to be annoyed. These are some of the annoyances that I got, so can read through them. It takes me an hour to write a single test. That is pretty annoying. New tests just duplicate existing coverage, so why bother writing them? For example, if you have integration tests that overlap with unit tests, it might be difficult to see the point of writing unit tests for something that's covered with integration testing or kind of the opposite. Instability in testing suite, so it fails all the time for no apparent reason. It runs too long, so it's a pain to run locally during development phase, and then you end up shipping bad code to staging or eventually to production. It can be distracting if you have to constantly pause to run tests. It's not very enjoyable. It's also not very fun to set up. Some people have complained about that. And then also the problem of deploying when you have a huge test suite can kind of be a real pain when you want to ship features as fast as you can, and you have to wait an extra 10, 15, some people an hour to run their tests before deploying can kind of seem counterintuitive. The good news is that for the last part of this list, there are some pretty simple, still a bit complex, but generally simple strategies that you can use that use Docker or containerization patterns, different virtualization patterns to kind of ease the pain. The ones at the top are due to generally poor software architecture, poor design. If you have duplicate test coverage, instability, intermittent failures, those are things that we can't address using Docker. Docker will not help you. But for the rest of it, Docker is a pretty good way to execute your testing steps a little bit faster. So it can't alleviate all of the frustrations, but Docker certainly can alleviate some of the frustrations that you have with testing. And we'll start by looking at testing using a tool from Docker called Docker Compose. Docker and testing are, in general, a great pair. They seem to fit really well together, and if you know a lot about Docker, or if you've worked with Docker a little bit, you know that Docker's sort of claim to fame, or the reason that a lot of people use it, is that it's very easy to create consistent, reproducible environments with Docker. And if you think about testing in the scenarios which testing is very successful, it's when it's in an environment that's identical to development, to production, etc. So you want to be able to create the same exact environment over and over again without any surprises. And Docker makes that pretty easy. And if you do use Docker in development, chances are that you're probably using Docker Compose or maybe a different tool for application templating to set up your development environments. Maybe you have a script that just sets up all of your containers. Maybe you're using Docker Compose. Maybe you had used Fig in the past. Fig is now Docker Compose if you haven't been keeping up with the developments in the Docker ecosystem for the last, I guess, many months, but Fig kind of has a new name now. And so chances are, if you're using Docker Compose to set up your dev environment, you maybe just stop there. You use it for development, but not anything else. But the great news is that you can kind of extend this and use Docker Compose, use your environment that you have for development via Docker Compose for testing as well. So there's no need to kind of interrupt what you're doing, start a new testing environment. You can just sort of interact with your development environment to use tests. And I'll show you how to do that. It takes a little bit of work, but it's nothing too bad. So I'm going to use Rails as an example throughout this talk because I find that it's really approachable for people who maybe are non-technical, or if you're familiar with any programming language, chances are you can understand Ruby, and Rails are pretty easy to understand. This is a Docker Compose file, which is just a YAML file. So in this example Rails applications, it's a pretty simple one. I have two services. So we can see app and Postgres. Postgres is just pulling down the Postgres image from the Docker Hub. So this is nothing too intricate. There's no Docker file. There's nothing. I'm just pulling down an image and running it out of the box, so to speak. And I don't have to do anything with it. The app, though, I have to do a little bit extra. So this is my own application, and I am going to be building this service from a Docker file. So I have to pass in the build context, or kind of the location of my Docker file. So we'll say we'll build it. I have to give it a command to run. So in this case, I'll run it with Rails server. I'm also going to mount a volume because this is development mode, and I need to somehow have a way to get the code that I'm running in the container, and be able to interact with it on my local host or my development environment. I do that via volume mount. We'll bind a port so that I can see it in the browser, and then finally link that service to Postgres so that app knows that it sort of has a dependency on Postgres. So my development workflow might be something like this, given that Docker Compose file that we just looked at. So I might have that Docker Compose file in the root of my application directory. So I can git clone my application. I can say Docker Compose up. I can do a little bit of work, but then things kind of fall flat because it's not super clear on how to make tests happen given that development workflow. You might be tempted to just take the Docker Compose file when you're ready to run tests, and instead of giving it a Rails server, or kind of the start command for the Rails server, you might be tempted to pass in your testing command instead, which might work. Then you might be able to say Docker Compose up and then run tests this way. This can be a bit cumbersome. You're having to change the Docker Compose file. And chances are you probably have to do a bit of setup before running tests. So that example, while it's very simple, might not work for your use case. You may even need a different Docker file completely. If this is the way that makes the most sense for you to test, the good news is that Docker Compose does make it easy to kind of just modify the commands and modify the Docker file. So if you're unfamiliar with Docker Compose, or maybe are just getting started with using the tool, you can say Docker file and give it a specific Docker file to use. So it's possible to have multiple Docker files in the same directory. So you might have Docker file test for your kind of testing application. You might have Docker file dev or Docker file CI, et cetera, depending on the needs of your particular piece of software. So you could modify the Docker Compose file to look like this, and then run Docker Compose up and have rake test execute against the service that you build using your Docker file test. So that might work just fine. It's a very simple example. It might not be useful for you, but it's a pattern that you can use. Before we get too much further into kind of testing Docker Compose and running containerized services alongside of one another, I want to point out that dependencies are hard in this case. It's not just a given that if you have an application and a database, for example, that the application will know when your database is ready to accept connections. A lot of the declarations that you make at the Docker level, so for example, linking or doing something like relies on, depends on, etc., those are Docker level commands, not service level. So Docker might think that Postgres is up and running, and Docker's probably right, but that just means the service is running. That doesn't necessarily mean that Postgres itself is ready to accept connection. So Docker can't really have insight, so you might have to use something like a wait for DB script, etc., to make sure that you have the correct order and that your services are ready to be consumed before you start asking for them. So that's one pattern that we talked about, is just sort of modifying your Docker Compose file. This is kind of a separate step, but you might prefer to run your tests kind of alongside your development environment. So within your development workflow, alongside your development services, not as a separate step like we just described. And the way to do this is to simply run one-off commands against a service using Docker Compose. This means that you will keep the exact same Docker Compose file that you use for development, but just execute commands against the services that are already running. So this is not changing the Docker Compose file. It's not kind of modifying using a different Docker file itself. It's just running commands against the same set of services that you already have running. And we'll look at a quick demo of that right now. This is, again, a really simple Postgres Rails application. And if I look at the Docker file for this application, it's really simple. Just pulling down Ruby, we kind of install a couple dependencies, copy over the gem file and the gem file lock, and then run a bundle install. Nothing much, just pretty bare bones kind of Rails application. In the Docker Compose file, it's pretty similar to the one that we looked at in the example. We have an image, Postgres for the database, which I have aliased to call DB. We're building the web service using the Docker file that we just saw before, exposing a port, linking a volume. I'm setting the command right here in the Docker Compose file instead of setting it in the Docker file, kind of up to personal preference, but I find it easier if I want to maybe switch between running Rails or running some rake task at the Docker Compose level to keep the command in the Docker Compose file versus the Docker file. That way I don't have to rebuild the image every time I change the command. And then finally, we'll link the database to web. And I already have this running with Docker Compose. I have aliased Docker Compose to DC because I hate typing, which is why I became a software engineer. So if you're confused as to what that shortcut is, it just stands for Docker Compose. But I have these running already. And we have some tests in this Rails application that I'd like to run. And I can do that just by simply saying Docker Compose run. I want to make sure that we're running it with the right Rails environment variable. So I can say -e Rails n equals test to pass in the test environment variable. And then I'll pass in the name of the service that I want to run the command against. So notice that I'm typing web instead of Postgres Rails web 1, which you can see in the Docker Compose PS above. In my Docker Compose YAML file, I call the service web so that I will call it web whenever I call it. On the command line, for example, the Postgres Rails web 1 is the name that Docker Compose calls it, but I can just say web. So I have this set up, and then I can just run whatever test against this service in this, or whatever command. In this case, I want to run tests. And I had 12 tests that ran, and they all passed, which is really good. And under the covers, we can see that what happened is that there's actually a new container that kind of spun up and just executed this single command. So I still have these two that are up, my normal Rails application and then the Postgres service. but it ran rake test in a separate container. And I was able to do that without really interrupting my development workflow. So nothing changed at the Docker Compose level. Everything is just as I expect it to be. But I was able to run a one-off test. So you can imagine if you're running some kind of auto testing suite that you could kind of have auto testing running in the background alongside your development containers. And it's not very invasive into your normal workflow. It kind of feels very natural, like if you weren't running services and containers. I like it because I don't have to set anything else up. So I just can pull down my repository, pull down the files, run Docker Compose up, and then I'm ready to do development, ready to test, ready to do everything. I don't have to do extra stuff. So there's a couple extra kind of things you can do, some more, not maybe more advanced techniques, but just sort of getting into it a little bit more. In your development workflow, so from start to finish, you might do something like Docker Compose up. I generally run it with -D, just so that I don't, in kind of like the detached daemon mode, just so I don't see all the log output. That way they're running in the background and I can choose to see logs or choose not to see logs if I want to. So I'll set up Docker Compose up, have my application running. Then using the same technique we just saw with running one-off tasks against a Docker Compose, a service that's running with Docker Compose, we can run things like DB setup or run other database tasks against that to set up our testing things, and then just run tests against them this way. So this would be sort of the start to finish, all the stuff you need to do, of course, with this very simple Rails application, but to get tests to run in the development environment that you've already set up. You can also add a couple extra config options. If you need to, you can, of course, set environment variables with Docker Compose. You can do that in the Docker Compose level. You can do it at the Docker file level. You can do it at the command line level, of course, like you just saw. There's a couple different ways to add the extra options suited for your needs to make this run really nice. You can, if you'd like to, also write a script just to do all the testing. It's kind of a lot of typing, especially if you want to run things with different environment variables, and remembering the order of the arguments can sometimes be a little confusing. So you might want to just write a run test script and drop that in into your project, so that when you pull it down from GitHub or Bitbucket or whatever you're using, then you just have everything that's right there. That way you can Docker Compose up, run tests, you can stop, remove the containers, do whatever you need to do, and everything's self-contained in the project right there for you. The great thing about using Docker Compose for development and then for testing is that Docker can deliver for you a predictable, reproducible testing environment. So if I have this project pulled down and I'm running these tests on my machine, I can trust that my coworker who's on the other side of the really other side of the globe, in my case, I can trust that what he's pulling down is going to behave in exactly the same way as what I'm using. So it's not only helpful to me as an individual contributor, but it also helps my team work better together, because we're all on the same page. We're all working on the same stuff. There's no weird works on my machine stuff, because if it works in Docker, it works in Docker, period. So taking this a little bit further, we kind of looked at the local implications and local things that we can do. So testing during development, things like that. But if we want to put this testing into kind of the bigger scope of work that we as software engineers usually do, that probably means continuous integration. Somehow deploying code, we want to test in our continuous integration, continuous deployment cycles. We want to use Docker for this. And how do we do that? So continuous integration and testing, and therefore Docker, which we'll talk about how Docker fits into this in just a little bit, but they go hand in hand. So as I said before, if you have heavy reliance on continuous integration, continuous deployment, but you're not testing thoroughly, you might as well not be testing at all, because you can't really trust that when you get to the CI or CD step, that the code that it has gotten that far is not going to break. But I think that most of us find that CI and CD are indispensable to our workflow as a software team and to deliver quality software. And if we want a little bit of refresher of what this process really looks like, kind of from the big picture and why we do it, this is a pretty common workflow cycle for development teams. So we push code on a feature branch. We have automated tests that run just to double check our work and make sure that we are delivering quality code. And if those pass, then we can review and merge it. And then maybe that gets merged into master, maybe it gets merged into develop branch, or however you have things set up. Then checks should happen again, and then maybe it's ready for production. So there's a lot of back and forth testing, informing that code is eligible to sort of progress to the next stage in this CI/CD cycle. And what this cycle does is makes it so that the development team, so as you as an engineer, you don't have to focus on all of the stuff that we talked about. There's only a couple of parts that actually need human interaction. So of course, writing code, pushing it to a feature branch, reviewing is a very important step for humans to do. But humans don't really need to do the testing. That can all be automated. But again, we can only really trust that the system is working if we have adequate coverage and adequate test coverage for the automation steps that are running in between each of these review and merge steps. Relying on it without adequate test coverage is not a great idea. And if you're still not convinced, please let me suggest or posit this following situation. Would you rather find out your code is broken by seeing tons of 500s in production, or simply by seeing a failed run of your CI/CD system? So I know what I would personally pick. It's actually not that one. But I would really prefer to see a failed run of my CI/CD system instead of having PagerDuty awake me in the middle of the night. I know for a lot of teams, maybe taking the time for test coverage is hard, but I guarantee that it will make up for itself. Maybe not, you don't need to go and write all of them in one go, but incrementally increasing code quality, stopping the reliance on 500s in production to alert you to bugs is going to make everyone a little bit happier. So that being said, we want to run these tests. And what about running all of these automation steps like inside of a container? So we use containerization in development. Maybe we're using containerization during the testing step, during local development, and then moving to the CI step. We have all these tests, so why not run them inside of a container? And I want to just take a moment to talk about the pattern of using Docker to spin up other containers to run tests. So people have kind of this idea of, we run our unit tests in container during development, we should do that during deployment, which is right. And if we're running them in development in containers, we should be running them in production containers, and that is true. But I want to be very clear about where this pattern is appropriate and where it starts to kind of wander into insecure land and wander into bad pattern. And that kind of starts in the Docker and Docker land. So Jerome from Docker, if you are a fan of knowing the guts of Docker, knowing different security things about Docker, knowing pretty much all there is to know about the underpinnings of Docker, I highly recommend that you check out his blogs, his talks. He is really, really good at explaining things that are hard to understand and making them very easy to understand. But basically, the gist is that if you run Docker in Docker, it is not 100% made of sparkles, ponies, and unicorns. And I'll explain why just a little bit and why it's so important that I'm including this now as you get started on your Docker and testing journey. So you may have Jenkins running in a container, and this is probably fairly common if you are using Docker and you're using Jenkins, chances are you're using them together. So we might have Jenkins running in a container. And during the build runs, we want to create more containers. And Docker kind of makes this look like, well, okay, I'm going to nest those containers during the build inside of the container that Jenkins is running in. So we end up with something that looks like this, where we have kind of a parent container, and then we have child containers. And this might work 80% of the time, might even work 95% of the time. You may not have any problems with this, but I want to alert you to like a couple security concerns, a couple other kind of lower level software concerns. So again, your mileage may vary with this, but if you're going to embark on the Docker and Docker pattern, if you're rolling your own CI system, please check out Jerome's blog about why this is maybe inadvisable. The long story short is that you'll end up mixing file systems, shared build cache, things like that, that is kind of hard to see when you're first getting started, but can be very, very damaging once you get a little bit more in depth. So I highly recommend you check this out if that's something that you, a system pattern that you're interested in implementing. I will offer an alternative by binding the Docker socket instead. So instead of running Jenkins inside of a container and spinning up more containers kind of during your testing steps, inside as child containers, what you can do is instead have them run kind of on the same level. So instead of having child containers, what we are aiming for is sibling containers. So something that looks more like this. We have Jenkins running in a container who is then starting containers for testing on the same level, not kind of nested within it. I do go back to this previous slide. Please inform yourself about security concerns if you do plan on binding the Docker socket. So there's a kind of a multitude of things to consider. It's not a blanket, this is going to work all the time, every time kind of thing. So please inform yourself about the kind of the negatives and the positives for both of these different architecture styles before you get started with them, just to sort of protect yourself and your company. So the next thing that we will talk about, kind of the final thing, is parallel testing with Docker. So we've looked at local testing, we've looked at a couple different kind of architecture patterns if you're interested in creating your own Dockerized testing system for your software. One other really cool thing that you can do with Docker, because containers are so ephemeral, is use parallel testing. We look back to this slide of why people skip tests. Most of them are related to time. We don't want to slow deployment down, it's too slow, it takes too long to run the test suite. And the good thing is that we can kind of really increase the time, kind of really increase the efficiency, reduce the time that it takes to run your test suite by splitting the testing steps up into many different parts, executing them simultaneously, and then bringing them together at the end. And the way we can do this is through Docker. But it kind of requires us to start thinking about Docker and thinking about containerization in a different way than we're used to, or a different way that it's talked about a lot. It's very easy to think of a container, especially when you're first getting started, that a container is just a small virtual machine that runs a specific workload. But I think a better way to think about containerization and containers in general are just extra processes. So if we can sort of remove the container as VM parallel that we have in our mind, it's easier to think about more interesting things that we can do with containerization, given that they are essentially just processes that are running, and what we could do when we have access to lots of different lightweight processes that can run simultaneously. And one way that we can use these processes in a really cool way is through testing. So we might think that testing is a step that looks kind of linear like this. So we have a person who writes code, she pushes code, then tests are run in this Docker container, which is kind of like a virtual machine, and then either it's green or it's red. But if we can kind of think about containers as a process, then we can maybe think about a different way we could handle this workload. So what if instead of pushing code and running the test suite in just one container, we split up the tests and ran them in three containers simultaneously, and then brought them together for the status at the end. And Codeship has a tool that does just this. It's called Codeship Jet. I'll do a short demo, and we'll talk about a little bit kind of the technological things, how it works, how we're using Docker, and the speed increases that we can see because of Codeship Jet. We use a syntax very similar to Docker Compose for service definition, and I want to just very quickly say that it is version 1 Docker Compose. There are a couple of things in version 2 that Jet doesn't support yet, but we're on our way to supporting them. It just it might not be tomorrow. So, but if you have version 1 Docker Compose files, then you'll be able to use Jet with no problem. And the great thing is you can just actually reuse your Docker Compose file itself. There's no need necessarily to rewrite your service definitions when you've already done them in Docker Compose. A couple caveats, but in general, no need to rewrite or create new assets. So this is, again, a pretty simple application. We have a web service, so maybe this is Rails, could be something else. We have Redis and Postgres. And we maybe have a couple commands. So maybe in this, we have like teaspoon, cucumber, rspec, I don't know, running multitude of other commands that we might want to run against this particular demo service. And what we can do is then take all these commands and kind of extract them into their own standalone container. So instead of running them sequentially, we could say they can run in parallel. Like, right, there's no reason my cucumber specs can't run at the same time rspec is running. So there's really no reason, especially when they have their own database and Redis instance. Then each of those is kind of standing by itself. So we have the sum test command, so this first container running with its own Redis and its own Postgres somewhere. And then we can have another test command running with its own Redis and its own Postgres somewhere. They need not be on the same host because of what we saw earlier with Docker being able to sort of spin up these very reliable, reproducible testing environments. So this could be geographically distributed. They could be on the same host. It doesn't really matter as long as there's a connection for the main tool, which is Jet, to know the exit status of each of these testing commands. And the way that Jet works is that we have basically the test runner, which is Jet, and then we have this kind of testing context. So we can run first test, second test, whatever test in kind of different locations, but we need to keep a relationship or keep communication open between the test runner and then the tests themselves. And I will go through just a really quick example of how this works. So this is a simple kind of Jet tutorial. I'll show you the link to this as soon as I'm done with this. So this is on GitHub, and if you want to pull it down and check it out on your own, you certainly can. We have two things. We have a Codeship steps file. So this is for the app service, which we can see here. So we have a couple different things. We have the app service, we have Redis, and we have Postgres. And what this test is going to do, so using Jet, we will kind of spin up this testing environment and then monitor the progress. And then at the end, we'll get an exit code. I can add as many steps as I'd like. And actually, I'll just add another one for effect. So we can, let's say this. And I'll run this just by saying Jet steps. So there are two things in play here. Again, the services, which was a list of services, and then the steps file, which actually says stuff to do. I ran this before just for the sake of time because I didn't want to be pulling down all the Docker images. But what we can the it's finished already, it's very quick, is that we have the the image build started, so we're using the cache because I've built it already. We can see Redis is being pulled and started, and that's great. So that was for one of the steps, which was the check sh step. But I also had another step, and we can see that there's in fact another instance of Redis being started. And this finished with success, and I bet if we go up here, we can see that these both finished with success. It's two kind of separate testing pipelines that are running simultaneously or simultaneously enough next to each other. So you have the choice of serial or parallel, depending on your own needs for your testing suite. But each of the testing steps does get its own environment, as we can see with the two Redis services that were started. And it's really fast because Docker is in general just very performant, especially if you can cache and write images in a really efficient way. And if you want to pull down a couple other things and try it out on your own, you can download the Jet tool from Codeship. And if you want to look at the tutorial that I kind of just went through and look at some of the other combinations on your own, again, there's you can configure it to run steps serially, to run in parallel, etc. You can pull it down from our GitHub Jet tutorial repository. And long story short is the way that this is possible is by being able to create very predictable, reproducible testing environments with Docker. And the very last thing that I want to talk about before we go into kind of the Q&A section is a kind of a super cool tip, which will kind of hopefully be helpful to you. I find it very helpful. If you're using Jet or some kind of parallelization tool to run your tests, one thing that's very helpful to increase code quality is to add an additional pipeline or parallel step, whatever you want to call it, to fail if the quality of your code decreases. And by quality, I mean things that are measurable like linting errors, like test coverage percentage, etc. So these are some of the kind of more kind of the hidden code quality indicators that we don't always think about or see because generally they're not something that will fail a test. But if you can explicitly make them fail a test, it's an easy way to keep your code base a little bit tidier and keep the quality up. So we have, at Codeship, we do this with one of our bigger applications. It's a Ruby application, so we use a tool called Rubocop. There's a couple other tools that you could use depending on which language, but we just have a simple script that runs in a parallel pipeline kind of toward the end of our builds that looks at the warnings that we do have, so the linting warnings that we do have, and compares it against some arbitrary threshold. It could be 0, it could be 100. It kind of depends on where you are in your code base. So we don't have these as part of an explicit testing step, so it's not part of RSpec test suite run, it's not part of Cucumber test suite running, it's its own explicit step. The great thing about Docker and about Jet is that you can customize the tool to exactly your needs. So you are able to do things like this. Whereas with other systems, you might be tied to running only test commands. You can just run your own script. And the way this works then, even if RSpec passes a bunch of whatever other step passes, if my linting step or my code coverage step fails, then the build fails as well. So it's a really easy way to just add a simple thing to your CI setup that will help you keep your code a little bit tidier and nicer. And with that, I want to point out some resources. You can, of course, down in the bottom right-hand corner, see codeship.com/resources. So that's where you'll find a bunch of content related to continuous integration, continuous delivery, using Docker, parallel testing, etc. Have a couple other things if you're interested in learning more about testing. You can check out some slide decks on SpeakerDeck. If you are a Rubyist and you're interested in parallel testing within your application, you can use a parallel testing gem, which is pretty cool. Of course, don't forget about Jet, which is our tool about for CI and CD parallel testing. Docker Compose documentation, Docker and Docker, etc. These slides will be available online, so you can refer back to this resource slide to follow up with whatever you would like to learn more about. The last thing I want to close with before I hand it back to Manny is a quote from Dijkstra, which if you are kind of a computer science nerd, you probably know Dijkstra and have implemented some of his algorithms yourself as a computer science student. But he had a very profound thing to say about testing, that it is a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. And throughout this whole testing talk and emphasizing how important testing is, I want to make it really clear that testing does not and never will guarantee that your software works. That is just not possible. It can only tell you when your software is definitely broken. So testing can never assert that your software is 100% flawless, but what it can tell you is definitely when there is a bug. You will know because of your tests. But it's so important then to know when your software is definitely broken, because it makes the chance of introducing something really terrible into production so much smaller. And with that, I will say thank you and hand it back to Manny.
Thanks, Laura. Thanks for the great presentation. So just a quick wrap up from my side. As mentioned, Laura is actively working on our CI platform called Chat. And we try to bring native Docker support to hosted CI with Chat. And you saw a little bit of this of Chat in the presentation. So if you're interested to try it, you can head over to codeship.com/docker, and you can request a free 14-day trial. And we'll make sure to get you in touch with a dedicated Codeship contact. And that person will help you getting started, help you with support questions, and basically anything you might need. You will get a person 14 days that helps you with getting started with Codeship Chat. I'm also happy to announce that we've got a next webinar coming up at the end of April, on April 28th, where Brandon, our Codeship engineer, will talk about how to manage testing environments with Docker and Codeship Chat. And if you're interested, you can sign up for the webinar on the mentioned page. As always, it's free, and we would love to see you on April 28th. But enough from me. I know there's a bunch of questions. I tried to answer quite a lot of them, but there were some really interesting ones towards Laura. So I'm handing over to Laura for the Q&A session. Thank you.
Thanks, Manny. So we have just a couple minutes left for questions. Of course, if you don't have your question answered and are still really interested, you can ask me on Twitter. My Twitter handle is on the front page of the slides. It's @RhineWine with an underscore. So I am usually on Twitter periodically throughout the day and be happy to answer any questions. The first question that I'll answer comes from Stefan. Do you use Docker Compose for testing at different levels besides unit tests? So API tests, UI tests, etc. Yes, absolutely. In fact, I only, for, I guess, the UI applications that I work on, so for example, a Rails application where Docker Compose is useful and helpful. So obviously not on like a small Go application, I don't use Docker Compose, but for Rails in general, yes. I do all of testing. So whether it's UI tests, unit tests, etc., I am always using Docker Compose, and I'm always running tests in exactly the way that I showed, which can, maybe if it's not, if you're not used to it, might seem a little funny, but for me, it works really well. It's the way that I prefer to work. I should mention also something I didn't show is that I do use debuggers inside of containers. So for example, if I'm running a Rails application, again, we'll keep the same example, I will have pry inside of maybe a model that I'm trying to debug, and via Docker Compose, as long as I am not running in detached mode. So if I'm kind of looking at the logs as they're being outputted, and I can set a breakpoint and just start working. So that works in tests, in just running the application in development mode. either way. So I use Docker Compose for everything when it comes to developing. Okay, the next question, this is very important. Can I use Docker Compose and Dockerfile interchangeably? And the answer is no. So Docker Compose, your Docker Compose YAML file is an application template. So this is saying every single thing that your application needs to be running. Links, exposed ports, etc. If you have a Docker file and you just build your Docker file, you still need to run it somehow. So Docker Compose is kind of the runtime step. So what you could do is build a Docker file and then take the same information basically that you have written in your Docker Compose file and put that into your Docker run command that you run. But of course, then you have to run it and type all of it every single time you want to run the container or run your application. So you also can only run one container at a time with a Docker run command, whereas Docker Compose, you can say, here's my application, here's my database, here's Redis, run them all together. These are the relationships. Here are the exposed ports, volumes, etc. So they kind of work together, but they're not identical. They have very limited scopes as to what they can do and can't do. Similarly, you can say Docker build and pass in a Docker Compose YAML file. That just won't work. It has to be the right tool kind of for the right step of the process. Let's see. What is the ETA for JET compatibility with Docker Compose 2 from Chris Alexander? This is a great question. So if you pay attention to the Docker ecosystem, you will know that libcompose itself is not compatible with DC2. We have some dependencies such as that, so we are patiently waiting. I can't really give you a great ETA. I don't have enough information to be able to provide that, but trust us, we will have it working as soon as it's technically possible for us. So it's something that we would love also to have as engineers, because we do use Codeship for Codeship. Let's see, one last question, I guess, before we wrap up. This is a simple one from Dan. Are you running Docker Compose up for each test? So I am running Docker Compose up at the very beginning of my development workflow. So when I sit down at my computer in the morning, provided that I've shut the application down before I went to bed the night before, I'll run Docker Compose up just to boot everything. What I do run for each test is Docker Compose run, which is the command to run a one-off command against a single container. So I'll say Docker Compose run web rake test or cucumber, etc. So I do have to say Docker Compose run because, as we saw, this tells Docker to kind of spin up a separate container, a standalone kind of process to run the test, and then it exits. So I'm just setting up my application one time with Docker Compose up, so starting everything, but then when I run it, I actually have to say run every time. And that, I guess, is just about all the time we have. So once again, a huge thank you to everyone who stayed, used your lunch hour, used some time of your day to learn a little bit more. If you are interested, you'll have a recording of the webinar and slides available online. And don't forget to join us on April 28th, same time, with my coworker, Brendan Fosbury, to talk about managing testing environments with Docker and Codeship Jet. Thank you very much and enjoy the rest of your day.